So I'm going to talk about Async Ruby tonight or today. And my name is Bruno Sutic. You can reach out to me via my website, brunosutic.com, or this is my email, and my GitHub handle is Bruno hyphen. All right, so let's jump into the speech. All right, the topics are going to be, of course, asynchronous Ruby. That's going to be like 90% of this speech. But I also intend to touch on the concept of fiber scheduler, which is the underlying technology in Ruby that kind of, enables asynchronous Ruby to do its magic. All right, so it's probably going to be between 5 to 10% of this talk. All right, okay, so before jumping into asynchronous Ruby, I'd like to take a step back before even going full on into the speech and just touch lightly on the topic of asynchronous programming. I mean, I know this is funny. We're in a Ruby meetup, right? And I'm going to start with a JavaScript example. But yeah, I mean, I think it's asynchronous programming. And if you've ever been programming anything in JavaScript, really anything, you probably kind of got a feel about that asynchronicity from there. And that is just what I want to kind of remind you. So you know, this concept is familiar to you till the rest of this speech, right? So if you ever coded in JavaScript, you probably did something like this. Like this is a fetch function, and it's reaching out to this HTTP bin.org. It's making an HTTP request, and then it's doing something in a as a promise, or maybe you did something in a callback. This is effectively it. And then after this code snippet is done, it's just doing something else. It's printing something to the console, right? Now, if we ran this code in the browser, we would see something interesting, right? We would see that runs first is output first, and that is effectively the last line of the code on this snippet. And then the status is 200 would be printed after that. What's interesting here is the last line of code outputs first. And then, the callback or the second line of code is output like the last, right? So the flow of execution of this program goes like line number 1 would trigger an HTTP request. Then we skip something. We skip the callback practically. Then we ran last line, and then we go back and execute the callback once the HTTP request is done. So yeah, I mean, as you can see, this is like a minimal asynchronous program, and it's all over the place. Line number 1, line number 4, and then going back to line number 2, right? So just a heads up, asynchronous programs sometimes have some mental overhead. It's not always that we go in a classical programs like top to bottom, line number 1, 2, 3, 4, right? Just synchronously executing the program top to bottom. Asynchronous programs sometimes go like all over the place, right? And I kind of started this example, showing you like the downside of asynchronous program. But what are the upsides? Like, why would you even consider doing this in JavaScript or in any other language, Ruby included? And why we make programs asynchronous? It's because of the performance, right? The previous snippet maybe did not illustrate that well, but let's do another JavaScript example. This time it's like just a plain pseudo code where we have 3 requests, right? Each of the this is something I did not mention, but each of these HTTP requests lasts for 2 seconds, right? So this is like a long HTTP request. Why is it 2 seconds? Like, why 2 seconds in particular? Because I'm specifying that in the path of the HTTP request, right? This is like the HTTP bin website, which allows us to do stuff like that, like maybe change the length of the HTTP request based on some parameters of the URL, right? So we're making 3 long HTTP requests and then doing something totally irrelevant in the callbacks, right? And if this was asynchronous code, it would do, the math would be 3 times 2 equals 6 seconds, right? But because this is like an asynchronous example, the whole program will run in about 2 seconds, right? Maybe slightly more because of the network latency, right? So in this case, like the math goes 3 times 2 seconds equals 2 seconds, which is amazing, right? This is what we want. We don't want things to last, longer than necessary or longer, or we want programs always to be faster rather than later. So that is the example why anyone would want to work with this asynchronous paradigm, even though some languages like JavaScript have some downsides, of course. By the way, just like a spoiler, Ruby does not have this downside of having callbacks, and we are going to get to that in some later slides. Okay, so back to Ruby. There's not going to be any more examples in any other language other than Ruby. All right. So by default, Ruby is synchronous, right? Like Ruby is not asynchronous. Ruby, but by default, right? Like it does not have like this concept of asynchronous HTTP requests that then require callbacks. Nothing similar in Ruby by default, right? In Ruby, the code is run in that classic top to bottom approach, right? Line number 1, requires some file. Line number 2, make an HTTP request, wait until it finishes, and then move on to line number 3, and so on, right? Like top to bottom, step by step. And in this case, like, what is the downside? What's wrong with this approach? Well, in this case, three HTTP requests that each last 2 seconds will run for 6 seconds, which is significantly longer than 2 seconds we had in this JavaScript example, right? So, I mean, that's like fine for a small number of HTTP requests, like this, trivial example. But, if you have hundreds, thousands, more of these, network requests, you kind of start to wonder what can we do to speed things up, right? And the classical solution for Ruby to kind of speed up our slow, programs that do a lot of requests is like, the answer is threads, right? You use threads to speed programs like this, right? And this is a quick and short rewrite of this previous Ruby snippet using threads, right? It will go like, we repeat something for 3 times. We will spawn a thread, right? We spawn a thread, inside a thread, you do a HTTP request, and then you call join on all 3 threads. And in this time, this snippet, I'm not going to run it, but like, you can trust me, it runs in about 2 seconds, slightly more, again, because of the network latency, but that's it. And that's a solution how we do things in Ruby. You use threads. And now you're wondering, like, are we good, right? Like, we're good, that's a solution, and end of the talk, right? Well, not so fast, right? I'm not sure if any of you guys have done anything seriously with threads, but threads have some serious downsides, right? Not just in Ruby, like just threads as a technology. There are some downsides. There's some complexity that go with threads. Let me just start by saying, look, threads in Ruby, or like anywhere, but like in Ruby as well, threads are hard. If you've done any like production level applications, I've done like one medium-sized projects with raw threads in Ruby, and let me tell you, like, it's hard. Things are complex, and when I try to like structure what is it really that's hard, there's 2 things that come to my mind, like 2 problems with threads. Is like, first one is language level race conditions, right? I'm not going to go deeper on that because this is like obviously not a speech about threads, but that's one problem that really is, like, if you do like a tutorial on Ruby or threads, you're going to get familiarized with what that means, of course. And the second one, in the context of like really scaling your application, is the maximum number of threads. It's like, look, I think the recommended maximum number of threads for the applications is like 50. Maybe if you have a special use case, like you can go and use like hundreds of threads, like maybe you can go a couple hundred threads in your application, but anything beyond that is like really like unexplored land. Like that is something I think is not recommended to do. On the other hand, we're going to see with async Ruby, you can really crank things up, and we're going to do an example that just scales easily into a couple thousand, a couple thousand operation per program really easily. So yeah, we're going to see that async Ruby is much more scalable than working with threads. Okay, so on to the main topic of this speech, async Ruby. Like you're probably wondering by now, like, what is this thing like that you're talking about? And I'm going to start by just saying that it's a new type of concurrency in Ruby, right? Concurrency is like this vague, advanced word that you use to explain many things. So let me just compare async Ruby with similar technologies that we use in Ruby today. First off, like the first kind of logical concurrency option that you can do with Ruby is processes, right? If you have many, like classical example, classical problem, if you have many HTTP requests to make in your Ruby application, you just spawn multiple processes and there you go, things will go faster, right? Another approach that you can take is like relatively new and is Reactors, right? That is something that allows you increase the concurrency of your program in Ruby. There is this warning about Reactors, and let me just say that the last time I tried Reactors, they were not ready for production in any way. I was easily able to crash Ruby a program, but it's an option. Maybe it's improved in recent Ruby versions. And yeah, so it's an option, right? Third one is threads. We mentioned it briefly, like they're popular option to increasing the concurrency of your Ruby program. And lastly, now since a couple years back, we have async Ruby, right? Ideal use cases for async Ruby is let me just say it like really succinctly, is like when you have a lot of IO work to do in your application. And the IO means input output, or in other words, if you have like a lot of network requests to make in your application, right? Be it if the protocol may be like HTTP, it might be some other protocol. We'll see examples with Redis. We'll see it could be something like email protocols, like everything that you do with your network. That is an ideal use case for async. Other examples would be like, if you have an HTTP client and you just want to make more requests in a short period of time, async is a perfect use case. If you have a web server and you want to handle more requests, async is an ideal use case. Also handling more WebSocket connections with your app. That's also a great example use case. Okay, another thing, like, just continuing about like what is async Ruby. Look, I mean, put it bluntly, it's a gem, right? There is a gem called async. You just do gem install async and you're good to go. And we're gonna see examples really shortly about like how all of that looks like. Look, what makes async special, like this gem, right? Like, why is this gem special? Why am I talking about it? Look, it received an invite from Mats, the creator of Ruby, to join Ruby standard library, right? The invite is still pending. In other words, it's not yet accepted. But look, I mean, if Mats recognized the value of it for the language, I mean, it really should tell something to all of us. And lastly, what makes this gem stand out is that the creator is Samuel Williams, Ruby core committer, right? So that really is something that should kind of be good about a gem. Okay. What else? What else is going on with async? Well, look, it's not just it is a gem, right? It's a core gem that enables everything else with async. But async is also an ecosystem of gems. So it's not just one gem, it's multiple gems. So you have something like async HTTP, which is of course built on top of async the gem. And async HTTP is a really popular HTTP client. It's not really popular, sorry. It's a really powerful and performant HTTP client. There's also Falcon, which is an HTTP server, and some of the, just like the highlights, it allows working with HTTP2 in Ruby. So if you need to have an HTTP server in pure Ruby, Falcon is the way to go. Also really performant. There's also async WebSockets and async Redis. All right, so I feel like I've talked a lot about, the theory, what is it like, and try to kind of bring it bring it with some examples. But I think right now we should just do like a live demo, and I should really show you guys how it looks in practice, like the minimal example. So let's jump into it. All right, so part of my screen is kind of all right. I had a technical difficulty over here. All right, so let's do a first example. Okay, so this is going to be a live example. So just a caveat. Look, guys, I mean, errors happens. Something may go wrong, and in that case, if that happens, I will just tell you the expected output, what we should be seeing, and I guess we're gonna have to work with that. But I hope nothing wrong happens, right? Okay, so on to the first. Okay, go ahead.
Oh, I said you got this. Live code, you got it.
All right, thank you. Okay, so let's do a first example. We are so I have these gems installed obviously on the system. I'm prepared. So we're just requiring async and async HTTP. The async HTTP is not the topic of this speech. So just like it's a HTTP client. And I'm not gonna just explain really what it does. The focus really is on async itself. We are starting async with an async block, right? This async is in this case, it's a method, even though it begins with a capitalized A, and it's a block. And the block receives a task, right? You spawn asynchronous tasks by with something like this, task.async, and then you do something within that block. In this case, in the first block, we are making an HTTP request, again, to http://beep-bop.org. This HTTP request should last for 2 seconds. It will last a little bit more than that because of the network latency. This server that I'm logged in, that the example will run from, is in Europe, whereas http://beep-bop.org is in North America. So there will be, I think, like a couple hundred milliseconds of latency. Okay, so again, in the second task, we're spawning 3 tasks here: task number 1, task number 2, and task number 3, right? And each of them is doing like the same thing. It's just spawning. It's just making an HTTP request, right? So yeah, this is making 3 HTTP requests, and it's practically measuring the time. So the expected output of this example will be just like the duration and then how long the whole program lasts. And what I'm claiming is, look, this will, this code makes 3 requests, and each is, taking slightly more than 2 seconds. But all 3 of these requests will execute concurrently, and the whole program will last for 2.5 seconds, slightly, something around 2.5 seconds, which will indicate that all 3 requests ran concurrently. So let's run it. All right, there you go. So 2.4 seconds. Okay, I think the kind of proves the claim that, you know, all these three tasks ran concurrently. They practically ran at the same time, right? And again, you know, that is the benefit of async, you know, where you get to, you know, run things practically in parallel. Okay. Couple other notes about these examples. Look, I mean, I'm not sure, you know, maybe there's some, you know, beginners in the audience, but, you know, this may be wrong, like it's not wrong, but like weird and unusual. How come there can be a method that starts with a capital A? It's just Ruby, right? I just want to emphasize, this is not a special DSL. This is not some, you know, monkey patching. This is really like everything is just pure Ruby. And I even try to, you know, make a comment here that like this internet.get, it's making an HTTP request, and then you receive a response over here, and then you can do something like we could do something like this in response, right? Like this is all plain and pure Ruby. Okay, so I have a couple more examples over here that I want to show you guys. And, you know, so far we have focused on making HTTP requests, but in a previous slide I mentioned, look, async, the perfect example, perfect use case for async is any, you know, any network request or any other protocol. It's basically if your application is IO heavy. So let's maybe do another example, and we'll get to other protocols. So in this example, this is the second example, it requires, just like to mention this, it requires Ruby 3.0 or higher, right, to make this one work. But in this example, we're not going to use async HTTP. We are just going to use pure Ruby to make an HTTP request. In this example, for simplicity, I'm using OpenURI standard library, and I'm going to make an HTTP request with just calling URI.open. I'm going to make a same HTTP request, the one that lasts for 2 seconds. And in this case, I'm going to make 2 requests, right? 2 requests with URI.open. The claim that I'm making is this program, or, you know, these 2 tasks will run concurrently, meaning, you know, the HTTP requests will run in parallel. And instead of, you know, taking like 2.5 seconds plus 2.5 seconds, they will both finish in about 2.5 seconds. So let's run the second example. And it's 2.4 seconds, right? So that kind of proves the claim. You know, these 2 requests ran concurrently, right? The point of this example really is to show that with async, and if you're running Ruby 3.0 or higher, you do not have to use any special HTTP client. Async is capable of making regular Ruby methods work asynchronously. And if you ask me, that is magic, right? And not only that, like, let's do another example. It's really similar, but in this case, I'm going to use 2 HTTP clients. I'm going to use the URI.open, right? The same one as in the previous example. And I'm going to use just like HTTP party. That's a popular HTTP gem. And I'm going to make a simple HTTP request with HTTP party, right? So 2 different HTTP clients in this case, and each one is doing the same HTTP request, okay? And what my claim here is, look, even though it's 2 different libraries, they will again run concurrently. So these 2 HTTP requests will run at the same time, and the total duration of this program will be about 2.5 seconds. Okay, so let's prove that. Let's run the example. All right, 2.4 seconds. So I think that proves the claim. Okay. And yeah, I mean, look, if you're asking, look, what is this async thing doing? Like, is it maybe monkey patching the URI.open and also monkey patching HTTP party, you know, gems to kind of make them not work synchronously, but instead make them work synchronously, let me assure you, there's like no monkey patching that's going on behind the hoods, and you know, none of that, right? This is all clean and Ruby code that's enabled by async, and we're gonna get to the reasoning why. We're gonna get to the underlying technology that's underpinning underpinning this, what's possible here. Okay, let's do another protocol. In this case, I'm going to add Redis to the mix. Okay, and I'm going to spawn. So this above, this is the same example as in the previous one, and I'm just going to add another async task that's using Redis. It's a just like a thing that should also last for 2 seconds, right? And my claim here is we added Redis to the mix, and a Redis command also lasts for 2 seconds, and the whole program will also run about 2.5 seconds, which should prove that Redis is also running asynchronously here with the other HTTP requests. Okay, there you have it, 2.4 seconds. So yeah, I mean, that should prove that Redis can run asynchronously as well. Redis is also a popular gem, as you probably know. All right, next example. Look, you may be wondering, can we do database requests asynchronously? And the answer is yes. This example should prove that. I'm going to use the SQL, the library. This is just a setup that needs to be done. And I'm spawning another asynchronous task at the bottom. And this line of code is running a database query, calling a function pgsleep. This is a Postgres database that I'm running, and it should last for 2 seconds, right? And the claim, what this example should show you is that we can run database requests asynchronously and concurrently with all the other examples we have so far. This program should last about 2.5 seconds, the same as all the previous ones. All right, 2.4 seconds, I think we're good. And I think that proves that, you know, okay, you can make database requests asynchronously. I think we're on example number 6. Okay, this one is really simple, but I just want to show it, and that is, so I'm adding another async task to the bottom, and it's just doing the sleep and with 2 seconds, right? This is just sleeping for 2 seconds. Sleep over here is regular Ruby, like the built-in sleep method. And what this example is showing is like, look, you can also sleep concurrently with all the other async tasks as above, right? This example should also take about 2.5 seconds. So let's run it. 2.4 seconds, and I think we're good. All right, let's do another example. And this time, okay, so I'm adding another task to the bottom. And what I'm doing here is I'm running a system executable that is running an external command, right? I'm using also sleep too, so I can just control the duration of this executable. But as you might know, with the backticks, what this is doing is like so-called shell out, right? So this is actually running a system binary with the name sleep, which is doing exactly what the name says. It's just sleeping for 2 seconds. But this can be any other executable on your system, you know, that you need to run. The claim here is, look, this will also run concurrently with all the other tasks, and the example should take 2.5 seconds. So let's run it. All right, 2.7 seconds. I think that's probably because of the network latency variation. But yeah, I think that should prove that, you know, this runs concurrently with all the other examples. Okay, I think that was the last example, like last basic example. And all these examples showed like, look, we can make many different operations run concurrently with async. And, you know, there's no, it just works, right? Now, let's do like a scaling example. On one of the first slides, I mentioned that, you know, async is capable of really really, it's really scalable, right? And let's do a couple examples that should show that, right? Okay, so the first thing, sorry, that's a mistake. Okay, back to the example. The first thing that I'm gonna do is, so I'm gonna use the same example as the last one, right? We have various tasks doing various things. And the only change that I'm gonna make is just change this line over here. I'm going to repeat everything 10 times, right? So within this block, I have 6 tasks. So 6 times 10 is 60 tasks. So yeah, I mean, this is running 60 tasks. And my claim here is, look, we are making more work, and each of these tasks is lasting, or it requires 2 seconds to finish. But this program should run in maybe 3 seconds or something like that. Because everything will run concurrently. So I'm running the examples. Oh, wow. So it also took 2.5 seconds, right? So this kind of proves that we are able to run 60 tasks concurrently, and all these tasks executed at the same time. Another example, the only change, so we have practically the same example, and the only change I'm going to make is I'm going to run everything for 100 times. And so it's 6 tasks times 100. This is 600 tasks. And the claim I'm making is, look, it's probably take a little bit more, but it's not going to be a lot more. It's probably going to be like 3 to 4 seconds, maybe 5 seconds, I don't know. But it should be obvious that this is not taking minutes. This is all these tasks are running concurrently. So yeah, it's 4 seconds. It's slightly more than 2.5 seconds. But look, there is some overhead when establishing 100 HTTP connections to a remote server. So I think that shows, right? But I think this is proving to you guys that it's all running concurrently. And the last scaling example that I want to show you guys is just repeat everything for 1,000 times. I think I dropped something over here. Okay, yeah. This example is special because it's reverting back to using async HTTP. And the reason why I'm doing that is if I used other HTTP client, the overhead of making that many. So this will make 1,000 HTTP requests, and the overhead of establishing 1,000 HTTP connections would be just too great with any other HTTP client. And that's why I'm for performance reasons, I'm just gonna use async HTTP. All right, everything else is the same except Redis. We are also warming up Redis clients so that the example over here runs faster. Okay, this I have 5 tasks inside this block, so this example will run 5,000 concurrent tasks. The claim here is, look, it's not going to be 3 or 4 seconds. It's probably going to be like 6 or 7 seconds, but it should prove to you that it's all running concurrently. All right, fingers crossed, guys. This is the hardest example. All right, 8.8 seconds. Okay, so I think that was not so bad. And look, I mean, it's 5,000 concurrent tasks, and each task is running for 2 seconds, and all of that work is done in 8 seconds. I think that's really like impressive. So yeah, I mean, I think this last example really shows how easily, look, this is like a live demo that I'm doing. This is like a minimal optimization, and it's 5,000 concurrent tasks. Try doing that with threads. No way you can achieve that with threads. And again, this is just like a live demo. Async is capable of scaling much higher. Okay, So we are 35 minutes into this speech, and I have like intermediate async examples that I want to show you guys. Dan, I'll have to ask you, is it okay to prolong, so to break that 40 minutes speech target? If not, I think I'm afraid I'll have to skip these examples. So Dan, can you please tell me, are we okay just making the speech a little bit longer? How does the audience feel?
Well, we have the whole hour book, so I'm
Do
okay.
it.
All right, do it. I'll do it. Thank you, guys. I'll do it. All right. So look, all the examples we show so far, well, like they were really synthetic, right? So I want to show you, something more intermediate, like beyond the basics. And I'm going to show two concepts and a mix of these. So it's the example will be async semaphore, async barrier, and the combination of the two. All right. So since I'm short on time, I'm just going to dive right in. Okay. So what we have here is we are, the only new thing here is we're requiring async semaphore, which is a part of async gem, the core async gem. We are starting async block, and then we are initializing this semaphore, right? And we're going to get to the concept, what it really means, and what does it do? So we are also specifying number 2 here. And what this semaphore does is it limits the maximum concurrency of the tasks that are running via semaphore, right? So we are spawning 4 async tasks over here. And what we're doing is we're using semaphore to spawn new async tasks, right? We're doing semaphore.async and then pass it a block. So in this case, it's not like the tasks that are spawning new tasks, it's the semaphore that is spawning new tasks. And what we're trying to accomplish here, we are allowing a maximum of 2 HTTP requests at the same time to run, right? What that means is like we have 4 HTTP requests. If it's maximum 2 HTTP requests at the time, that means it will first run 2 HTTP requests at the same time. It will wait for them to finish, and then we'll do 2 additional HTTP requests, to kind of finish all the work. Okay, so my claim with this example is it will run 2.5 seconds and then plus 2.5 seconds because it has to wait for the first 2 requests, HTTP requests to finish. I expect this example to last anywhere between 4.5 and 5 seconds. So let's see how long it will run. Okay, 5.1 seconds. That's slightly above my estimate, but I think it's in the right ballpark. So again, I think this proves that like this semaphore really does the work, right? It really limits the maximum number of tasks that can run at the same time. Okay, so that's a semaphore, right? Look, I mean, again, this is beyond the basics, and it's okay if you guys don't understand, really what's going on. How come we're using semaphore to spawn new tasks, semaphore.async? I think the point here is not really to fully understand everything, because this is, this is new cutting edge technology, but like, just to get a feel of what's possible. Okay. Let's move on to the next example. And this time we will use async barrier. And async barrier is also a part of the core async gem. Okay, so we are spawning an async block, and we are initializing async barrier. There are no arguments that need to be passed by default to async barrier. And we're going to do something similar, right? We're going to repeat 4 times, repeat the block for 4 times. So the core work that will need to be done is we will spawn 4 HTTP requests. This time, we're going to use a barrier to spawn those 4 tasks, right? We're going to do barrier.async and then pass it a block. So this will run 4 HTTP requests. Then we're going to do barrier.wait, right? And look, maybe there's something that I should have said before, even explaining what the code does. But like with async, what I've noticed so far is like, it's really useful to have the common pattern is like you want to do some async work, and then you want to wait for all of that work to finish before moving on to some other work, right? For example, the common use case is you want to make a number of HTTP requests, then wait for all these requests to finish, like, you know, like do some kind of a checkpoint, and then move on to making to you know, in your program to do more work, something else, right? And this is exactly what the barrier enables us to do. In this case, we're going to make 4 HTTP requests, then we're going to wait for all of them to complete. I'm going to output how long it took, and it should take about 2.5 seconds for those first 4 requests to finish. And then I'm going to do some more work, and in this case, I'm just going to fire another HTTP request, and the whole example should last from about 4.5 seconds to up to 5 seconds. Okay, so let's run it. Okay, so this is the first checkpoint. It's like the first 4 HTTP requests ran in about 2.5 seconds, and then we spawned that last HTTP request, and the whole program ran in about 5 seconds. So I think that kind of illustrates what's going on here. Again, barrier is really, really useful, and if you start playing with async, I think you know, it's something you will definitely use. Okay. Last advanced example, or sorry, last intermediate example is a combination of a barrier and semaphore. And I think, look, this is even more advanced, like a little bit more advanced. You know, it's showing how you can combine a barrier with a semaphore, right? And look, again, it's completely okay if you will not understand everything here, but I just want to show you guys what's possible so you get a feeling, right? So in this case, we are initializing the semaphore. Again, semaphore is used to limit the number of concurrent tasks. We will limit the number of tasks to 2 again. Then we will initialize a barrier, right? The new thing here is we're going to specify a parent for the barrier, and the parent is going to be a semaphore. And with this argument over here, we're kind of combining the barrier with the semaphore, right? Then we're going to spawn 4 async tasks, 4 HTTP requests, and we're going to do barrier.async. So the barrier will be used to spawn those tasks. We will wait for those 4 HTTP requests to finish, log the time, and then perform the last task, and then log the complete duration of the program. So my claim over here is, look, we are combining an async and a semaphore with a barrier over here. So instead of making 4 requests at the same time, we're going to do 2 requests, then wait for them to finish, and then do 2 additional requests. So this first checkpoint will be will last from anywhere between 4.5 to 5 seconds, around 5 seconds. We're going to do another async HTTP request, and the whole program should last about 7.5 seconds, right? Okay, let's run it. That's the first checkpoint, and that is the whole program duration. So about 4.5 seconds and about 7.5 seconds. So look, I think this should prove that, you know, here, this is not running all the requests at the same time. This is doing first 2 requests and then wait for them to complete, and then letting those last 2 requests to finish. This is how you combine multiple concepts with async. In this case, it's semaphore and barrier. And, you know, this is how it works, right? Again, this is a more advanced example. It's completely okay if, you know, if it's all like new to you. All right, so those were all my intermediate or like advanced examples. Let's go back to the slides. Okay, okay, so we covered a lot, really, you know, and you can feel that this is like a lot of it is like magical, you know. For me, I think the main question is like, in one of the first slides, we were able to run this URI.open method in Ruby, and it ran synchronously, right? Wait for the first HTTP request to finish, move on to the next one. And how come we can use the same method in Ruby inside async block and have it run asynchronously? And there are three underpinning concepts that enable that. The first one is event reactor. The second one is fibers. And the last one is fiber scheduler. Honestly, like these are all like really advanced concepts. And if, you know, I could make a speech out of each three of those, right? They're more theoretical. So I'm just gonna mention them, all of them briefly. Okay, first one is event reactor. Event reactors have other names, like you may be using event system or event loop, but the underlying technology is of course the same. So for example, on Macs, on Apple's machines, you have KQ, something that's called KQ, and that is, you know, for Macs, that's event reactor. And Linux has something that's called POL or ePOL, right? That's what event reactor is. Async version 2 is using an IO event gem, which implements the event reactor, right? So event reactor is not implemented directly in async gem. It's kind of in a way delegated to the IO event gem, which uses, you know, is implemented in C to interact with you know, these event systems. Like, how can we explain this event reactor in simple terms, right? It's used when you make you know, many you know, network requests, right? And event system is enabled, is a technology that can tell you, okay, like you are making many HTTP requests, and look, this response over here, it received a couple more bytes, and now it's ready for the application to read that response, and you should go and check it out, right? Of course, that's all done in an automated way, and this is like a low-level technology. So this is not something you would be interacting in your own programs, right? And event reactors allow async and other programs. Really, the benefit is scale, right? Event systems allow programs to scale, you know, to making thousands, if not hundreds of thousands, HTTP requests. The second big piece of technology are fibers, right? We have not mentioned fibers directly, but you know, that is like the low-level concepts behind async tasks, and we have mentioned async tasks. The base feature of fibers is they can be paused and resumed, right? So I think the best example is really in the async, and this is like just a simple example where we are running 3 HTTP requests, but they are done synchronously, right? We're spawning a task over here, start a first HTTP request, okay, write some Ruby code, then spawn another HTTP request, write some Ruby code, and then spawn another HTTP request. In this case, this task will be paused and resumed as the requests are started and received, right? In this case, while we're waiting for the HTTP request to finish, the task will be paused and the execution control will shift to some other task, right? Once we receive the response for this request, this fiber or this task will resume. It will work through some Ruby code, and then it will fire another HTTP request and then pause the task and be received when the response is received, and so on and so on. So yeah, fibers are what allows us to, you know, pause and resume some code. The good thing about fibers, and while they're really special, is we can write asynchronous code and not have to deal with callbacks, right? Callbacks are infamous, especially in JavaScript world, because they lead to something that's called callbacks or callback hell. With async Ruby, you will never have callback hell. In most of the cases, you will write completely synchronous code and then maybe sprinkle some async code here and there, right? Fibers are also like, it's a deep topic, right? And I've like kind of investigated a lot because I wanted to learn all about it. And really the most, like the core, like the way to really succinctly explain fibers, if you ever really want to study it, like, look, fibers are something that's called stackful coroutines. This is kind of hard to grok, and it's not the topic of my speech, but if you ever dive into into fibers, just keep in mind and search for stackful coroutines. Okay, the last big topic of this speech of the concept underlying async Ruby is Fiber Scheduler. Fiber Scheduler was a big Ruby 3.0 feature. You probably have not heard of it before because, look, it's a pretty low-level technology, right? It's not intended for the programmers to be to interact directly with the Fiber Scheduler, but it is something that enables the magic of async Ruby. Effectively, it turns blocking behavior into non-blocking, right? And the Fiber Scheduler is the reason why you can write code like URI.open and have it behave synchronously in regular Ruby programs, and it can also behave asynchronously in async programs. That is the magic that Fiber Scheduler is enabling. And again, that's why URI open works the way it does. Okay, I wanted to show you some examples with Fiber Scheduler, but I will skip it because I have a couple more slides that I think are more important at this point. Okay, so you may be having questions. Hopefully I got you interested in async Ruby, and hopefully you want to try it out, you want to play with it, you want to learn more about it. And the big questions you want to know, you may have is, look, this is all cool, but does it work with Ruby on Rails? And the answer is currently yes, it does. A couple months back, an important PR was merged into Rails that enables active record to work, so async can now utilize active record, so active record queries can run asynchronously. That's a great achievement, and you look, async ecosystem and is evolving, and it's still a work in progress. But yeah, I think it's safe to say now Ruby on Rails can work asynchronously. Is it production ready? Short answer, really yes. It's a stable, async is a stable and mature gem by now. Okay, if you ever want to dive into async, if you want to play with it, there are some common gotchas. Look, I've seen people, kind of report problems, but because they're trying CPU-bound operations like mathematical operations, and they're trying to make them concurrent. Look, async will not have any benefits if you're doing CPU-bound work. The reason for that is because there's no blocking or waiting operations that can be made concurrently. Another gotcha, if you're trying to run things on Windows, you're probably going to fail. People are just reporting weird errors on Windows. It's just because async has not been tested extensively on Windows. So look, maybe just take with Mac or Linux for now. Okay, another thing, and this is a trap that I fell in a couple months back, and I tried using a raw Ruby Fiber Scheduler instead of async. Look, if you try doing that, dinosaur will show up and eat you and you're dead. I'm just kidding. Look, Fiber Scheduler currently is a really low-level technology. If you kind of investigate it, if you think you can do some work with it, well, think again. Really, if you want to make your work asynchronous, just stick with async gem. It's just much better suited for production use than a raw Fiber Scheduler. And lastly, like, look, I mentioned Rails, async support in Rails was enabled a couple months back. And like, you maybe, is Rails fully compatible with async? Like, will everything work? Look, not everything will work, right? This is a new technology. And there are probably some dark corners in Rails where you might receive errors. So just if you want to use Rails with async, just keep that in mind. Okay, how do you get started with async? Unfortunately, there are no tutorials, and I encourage everyone to read some source code from async repository on GitHub. For example, read some async barrier, read async semaphore source code. The examples that we covered, they do not have a lot of lines of code, and they're quite approachable. Once you're done with reading some source code, I encourage you to check out async HTTP gem. I want to highlight Samuel Williams. Samuel Williams is the creator of Async Ruby. He is a Ruby core committer that got Fiber Scheduler into Ruby 3.0. This guy is the mastermind, is a genius mastermind behind this. And really, you know, he's doing an awesome work. Conclusion, look, I really hope I got you excited about Async Ruby. It's a new type of concurrency. It's very scalable, powerful. The ecosystem around async is growing, and it's really awesome, especially as compared to async in Python or Rust. That these languages are really struggling with async. If you ever dive into Ruby's async, it's just plain awesome. Thank you, guys. I'm open to questions, and I'm aware that we might not have time, and thank you for letting me speak for so long. Again, my contact, if you need to reach out to me, I'll be glad to answer any of your questions via email as well. Thanks a lot, everyone.
Let's give Bruno a hand.
Thanks, everyone.
Sorry, I had it on mute.
No worries. Great talk. To tie
Awesome.
back to the original question that you posted at the beginning, yeah, all of us are pretty much new to Async Ruby, so I think we all appreciate you introducing us to a technology that's new to us. Looks like we might have a few questions that were in the chat, so see, Rich, I'm still trying to look for the question that you posted earlier.
I'll rephrase it because he added some information. Awesome talk. Thank you so much, Bruno. I guess you kind of answered this when you did one of your examples, when you maxed out like to 1,000 or something, 1,000 times. I guess my question is, what is the best practice for when you should choose the async specific gems? And I guess it's when performance matters and when they're available. You should always use the async versions. That's my question. Okay, good question. All right. Okay, so let me just repeat how I understood the question. There is, for example, there is a core Redis gem, right? And there is async Redis gem. And when should you use async Redis and when should you use, you know, the vanilla Ruby Redis gem? It's a really good question. Honestly, I would say stick to pure Ruby gems because they are much, you know, like a much higher number of people is using core Ruby gems. So they are probably going to be much more up to date, much more polished. For example, that holds true for the Redis gem. It's much more up to date with Redis, the core Redis technology, than async Redis. Stick to Redis unless you really, really, really want to have some, you know, some screaming edge performance use case. Then maybe switch to async Redis if that makes sense. But at that point, you're probably, if you really have a screaming edge performance use case, you're probably going to be able to read through the source code of async Redis, which is not that big, of course, and then see if it really can enable that screaming edge performance. But really, the short answer is, look, stick to core Ruby gems. Do not jump into async gems, you know, for example, async Redis, unless you really need to, you know. I hope that answers the question. Thank you. Good question.
I have a question. There's your semaphore example.
Mhm.
It came out to a little bit longer than you expected. Do you think
Mhm.
that was due to the time when you had to create that instance, that semaphore instance before you actually ran the asynchronous code, or it was just something with
Yeah.
running Zoom on your computer at the same
Mhm.
time?
No. Okay, that's a good question. Look, I think the core reason is I'm running these examples from a server in Europe. I think they're in Germany, and I think they're making requests to servers in North America, right? So I think that's a big I think it's like 200 to 300 milliseconds latency each way, right? So I think that is the biggest variable in these examples. It's the network latency. Look, instantiating an async semaphore is probably a nanosecond, right? It's just a simple Ruby class. It does not take a long time. So yeah, it's not due to instantiating async semaphore. It's probably because of the network latency, which has varied for me while I was preparing for this speech.
Okay. Wow.
Cool.
So if your servers were closer, it might have gone faster.
Yeah, it's just that I'm running this server. I just didn't want to spawn a new one. I don't know, but yeah, if I probably spawn like a DigitalOcean instance somewhere in like US East or something, it will probably run. The latency would be lower.
Cool. Also, when are use cases for async? Like it, I mean, obviously when you're doing like a whole bunch of repetitive tasks, but just, I don't know, for any old business, like what, or
Mhm.
an app, what what have you used it for in
Good question.
that?
Yeah, you want something more specific than just like many network requests. Yeah, I got it. So look, I mean, I got into async like about 2 years back, and I have written a crawler, right? Like a web crawler, just as crawling websites is just a perfect example, a perfect use case for async, right? It's used primarily for making these potentially long-running HTTP requests. Crawl is great use case. Another use case where I think I have not used async for that, but I think it will be a perfect use case if you have something like an API proxy application, or to put it in other ways, if you have say a microservice in your app, and that microservice is used exclusively for interacting with some external API that's not within your company, right? If you have some like API that's maybe timing out often, or it's slow, and you just want to delegate all that code. You do not want to run it in your core application. You just extract it to external service application, and then have that application deal with those slow or slow running API requests, or requests that are erroring often. So I think that I've had this use case in the past. I have not run async, used async, because I did not know about async then, but I think that will also be a perfect use case for async.
Cool.
Yeah, that makes a lot of sense. Thanks.
Great.
Yeah, so I've been scanning the chat for questions. It looks like there aren't any more.
I got a couple.
Okay.
When can you speak to Reactor, or how do you say it? Reactor, or actor? I guess what is the right pronunciation of our actors?
Our actors, I think Reactors. I think Reactors.
So I've played around. I've followed your blog, and really I've sought out most of the stuff that I think that you've commented on. Really, really a lot of fun playing with this stuff. And I know Reactors are experimental. And is it true can you speak to the advantage of using a Reactor and when you think it might come out of its experimental stage?
Yeah. Well, look, okay. I think it's a good question. I think it is a relevant question to async, right? Reactor is like not really a competing technology, but it's an alternative choice to async. So I think this is a valid question. Okay, look, I'm much more familiar with async because I've used that much more than Reactors. I have evaluated Reactors. It's just that it was not ready at the time, and I think it was like a half a year, maybe a year back. It was just erroring all over the place. I was not able to do any meaningful work with it. Reactors, I just gave up. I'm not sure when they will, come out of experimental phase. But look, even when they do come out of this experimental phase, there are some gotchas to using Reactors. Like the only thing, the main thing I can think of is, look, you can use environment variables or the env hash, and I hope everyone is familiar with that. Like you just do env and then call some environment variable. You can only use these environment variables in the main Reactors. If you spawn additional Reactors, you're not allowed to touch environment variables. Why is this relevant? Look, maybe your program is not not touching environment variables, but most of the libraries Ruby, we in Ruby use, do use these environment variables. They do check these environment variables. For example, async itself in its internals, and I think in one of the depending gems, is checking environment variables. So if you were to run async inside Reactors, like that's a perfectly valid use case, and I have tried it. This is the exact example that I've tried. I wanted to run like multiple Reactors, and each Reactor would run its own async blocks. I was not able to do that because things, among other things, things were erroring because async was trying to access environment variables in secondary Reactors. So things were falling apart. So even when Reactors come out of experimental phase, there will be limitations, and the Ruby community will have to adjust for that eventually. So I think that is what I can say with certainty. That is my knowledge about Reactors, and hopefully that helps you evaluate things.
Thank you.
Jeremy, you have your hand up. Do you want to ask a question?
Yeah, please. Also, a quick comment towards actors, but first the question. So the way that it seems that async seems to be formulated is that you build the block to execute and it executes all at once. Is it possible to have a living block? So let's say I have, you gave the example of a web scraper, right? As you scrape the web, you pull in more and more requests that you then have to scrape. So that kind of feeds into itself. How would you go about doing that? Is that something that you have to set up kind of slides of activity, kind of like you build your slide, you run async, then you build up another thing, you do it again, or is it something that can constantly live? So that it can constantly feed new tasks and kind of run the fibers for that?
Yes, it's a great question. It is a little bit like intermediate question, but it's a great question. Look, yes, for making a web crawler, you would make just a single top level async block, right? And you would definitely do everything inside that single async block. And then how do you, like, I think your question is like, look, crawlers, you do not know how big the site is. You could have maybe 50 pages, or a site can have 1,000 pages, or maybe 10,000 pages. How do you know how many tasks do you have to spawn? And look, the answer to that question is you just do things recursively. And I think the construct that you use is the async barrier. Okay, we touched on the barrier in one of the examples, And look, what I have done in my crawler is you just use a barrier, and you use a barrier to constantly in a loop spawn new async tasks as you have these new web pages and new links come in, right? And then you just do fetch the page, parse the page, extract links, and then you have maybe 50 links. Okay, feed that back into barrier and spawn 50 new async tasks to crawl those 50 additional links. So again, if you ever try to do something similar, just remember, I think async barrier will be a really useful tool for that.
And just
Hopefully that answers the question. Yeah, go ahead.
For the most part, just the point about actors is that actors are an entirely different model, which is why if they don't work so well with Ruby, because actors are really meant to be concurrent across multiple servers. That's why they don't allow interaction with other types of memory. They were used, I know, a lot in back in the day. Akka was like Akka actors, part of the SMAC stack, which is big data processing stack. And the whole point of that is that if you define the unit of work to be solely enclosed, then you can kind of split it to any server you want. So in that manner, it doesn't, Ruby likes kind of to run on a single process, and it likes to deal with things on a single process. So it's not the best place to work with actors. I think Reactors are an example of the Ruby community being very excited about technology and wanting to build it in Ruby, even if it maybe isn't the best fit for it, just because of Ruby's limitations.
All right, thanks for the comment. I mean, seems you're more knowledgeable than me about Reactors. Thanks.
Hey, Bruno, sorry, I was like in and out, but what I caught, fantastic. I love that you're a hardcore Vim user. Seriously, like not only like you wrote all your code in Vim, but like you presented in Vim. Like,
Yeah, thanks.
good stuff. I'm not sure if this was asked before, but probably like, you get a huge performance boost using async, and it's great that we have like all the sample code, but where is a good way to use async in like an existing project to kind of get like a real speed boost or performance increase from that to and I think Rails is like the biggest use of Ruby. So probably like, hey, how do you do it for like a Ruby program? And then, hey, are there any tips and tricks around like Rails too?
Good question. It's a really, really good question. Okay, so let me just think how to best formulate this. Okay, so let me just say by starting, look, yes, I am also, so I'm using, from my experience, I have a couple standalone async only projects, and that is not part of this answer. But look, I'm also, yes, async can be used inside existing Rails applications. And let me just share the experience I've had. So the way I'm using it, so I have a Rails application that's a classic Rails app, nothing out of ordinary. And then I'm also using Sidekick, right? And then I have many, so that's not part of the existing crawler I have mentioned, but in that Rails application, I have, I think, a lot of async, a lot of HTTP requests to make. I think it's on the order of thousands, right? And look, I could feed thousands of HTTP requests to Sidekick, but then again, I would be slamming Sidekick because Sidekick has limits. Like I probably have two workers, and each worker has 20 threads, right? So I have like 40 Sidekick workers, and I have thousands of HTTP requests. So I would completely hog down Sidekick. So instead of hogging down Sidekick, I'm feeding Sidekick batches of work, right? So it's still background work, it's still Sidekick work, but inside Sidekick, I'm processing those batches of async, of HTTP requests. I think it's 5 or 10 HTTP requests in a batch with async, right? So I'm using Rails, Sidekick, and then inside Sidekick, so I have all the benefits of Sidekick. I have backgrounding jobs, great interaction with Rails, I have, if an error happens of something unpredictable, I have retries. I have, reliable, server deploys and all that, right? All the benefits of Sidekick. And then inside Sidekick, I'm using async to process, batches of HTTP requests faster. And the benefit is, if I needed thousands of Sidekick jobs before, I can, just divide it by 10 and now have 100 Sidekick jobs, and everything just runs much, much faster. I think you can do the same thing, in an like a regular, and I think I'm doing that in another place where I have a controller. Hey there, kid. I have a Rails controller where I need to make 5 or 4 HTTP requests, and then again, to speed things up, and just creating that async block, and then making those HTTP requests concurrent, just to speed up my controller response. Hopefully that answers. Those are the use cases I've used to. But look, you can just, it's all Ruby code. You can just use, async anywhere where it makes sense, and maybe you have some other use cases, or you come up with some other use cases.
So it sounds, well, the way I've done multi-threaded coding in my past life, and this is like in C, it's probably just taking like the profiler and working down and saying, hey, this is a block of code where it's kind of just churning through like a loop or a block of stuff, and this is where I can optimize and maybe use threads and get that going as well. So it sounds like similar idea. You kind of really need to know your code, and you just use the profiler and get it going.
Yeah. I mean, look, usually you kind of notice, right? Like a slow controller response, it takes like 4 or 5 seconds. What's going on there, right? It's probably some network request. And then you go from there, see if you can optimize it, see if you can make it concurrent, see if there's any benefits with either using threads or async, whatever makes more sense. Thanks for the question. I mean, this is a great question, by the way.
I'm going to throw another one out there if no one else has a question. Like if you're, let's say you're using async in the ways that you've shared. So do I have to, if I want to share the results and combine them, I'm going to have to just follow standard, multi-threading locking, like mutex locking procedures, right? There's no getting around that. Is that a true statement? Is that correct?
I mean, no. Look, that's the best thing about async. And in one of the first slides, I mentioned that threads in Ruby are hard, and they're hard specifically because you have to use mutexes and locks and maybe even conditional variables and semaphores. And, okay, we have semaphores in async, but it's a different purpose, right? With multi-threaded code, they're used for logging to prevent language level race conditions. Async does not have any of that, and you do not ever have to use mutexes with async. And so yeah, like you do not even have to think about locking.
So even in the case where, like, okay, let's take any of those examples that you did like 5,000 things at once, and let's say each one of those async tasks, you were updating for whatever reason, some global, scope level to that function, cumulative result. I don't have to lock that thing at all. It's defined outside of the async block, or does that variable have to be defined within the async block for that to work? That's what I'm driving at. Like, where you.
Yes. That's a great question. And look, I mean, I think this is a mission from my whole presentation and demo, and it's a great question that you're bringing up. Let me just make it absolutely clear. No locking necessary. You can use like a global variable called foo. Define it anywhere you want, like $foo, global variable. Any of those 1,000 blocks can make modifications to a global variable, and no locking will be necessary, right?
Wow. That's very cool.
Look, why do you even need locking with threads? because of the thread scheduler, which is really, really unpredictable, right? If you have a global variable called $foo, and then you $foo, you have many threads and that modify that variable. At each point, a thread scheduler can switch from thread A to thread B to thread C, and you don't know when, right? With async, things are much more predictable, right? And switching is done by the Ruby's fiber scheduler, because fiber is the underlying unit of concurrency that's used with async. And basically, switching from fiber to fiber happens only when you need to wait within a single fiber. And you only need to wait when you, for example, spawn an HTTP request, then you wait a couple hundred milliseconds. And at that point, the fiber scheduler is switching your work to another fiber. It never interrupts your regular Ruby, like that Ruby code, right? That's why you are able to safely modify global state. And this is one of the huge, huge advantages of async against threads. And that's why I'm saying, look, async is much more simple and easier to work with than threads. So thank you for this question. This is a great question. I think this is an omission from my part why I have not included this in my presentation.
Just want to throw one more out there. I read your fiber schedule article, which I really enjoyed, and I wrote those code pieces and stuff, and I used the default implementation, and is like, so if we're looking at async as it's implemented, would it be using sort of like what you discuss and using those default implementations, or when would you choose to go raw fiber scheduler versus async? I know you basically said don't do it, but I guess there, is there an exception to that?
Good question. Look, honestly, I have not yet found that exception. If you intend to write any, production code, like anything that you want to run on a server, or like, I just have to recommend async. I have thought a lot, even after playing initially, after initial investigation into Ruby fibers, like half a year ago. Look, I mean, it's very, very limited. It's very, very limited. I'm thinking on the spot here. Look, if the only thing you have to do is make a couple HTTP requests, wait for them to finish, and then move on, yes, maybe you can use raw fiber scheduler. But anything beyond that, if you need to limit maximum number of HTTP requests, if you need to wait for some HTTP requests to finish before moving on and spawning other HTTP requests, look, I just have to recommend async for everything, because these are common use cases, and you're probably gonna, just need them. And then in that case, a raw fiber scheduler in Ruby will become lacking, and you'll have to refactor. And so I'd say just stick with async so far.
Very good, thank you.
Thank you for your questions. These are great questions.
I feel all the information you've given us here in this talk and in the work I've found of yours previously, it's just fantastic. It's just a great way to inform the entire community about what's going on in the space.
Yeah.
And thank you very much.
Yeah, thank you. I mean, look, I'm just like, kind of the messenger here. I really need to emphasize this guy, Samuel Williams. He is like the genius behind all of this. I'm just writing a blog post here and there. He is, just, yeah, a genius programmer. Invented all of this for us.
When do you think he'll actually accept the invitation to bring all that stuff into core Ruby?
Yeah, it's a good question. I think I'm not sure he'll ever do that. We're in Slack, in some Slack group, and I think someone asked him this question, and look, I think this guy is really humble, and just to provide some context, in Python, I don't know anything about Python. I just know that there are multiple async implementations, right? You have a core. They kind of invited their first async package into the core library, and I think it's called AIO, right? So it's an AIO package, and then a couple other async implementations appeared that I think have even some advantages over the core package now. So you have a couple really good async, like really good. I think async Ruby is much better, but like you have a couple good and stable and mature async packages in Python. And you know, so the community is somewhat fragmented in a good way. You have multiple options. But like the main async package is, I guess, lacking in some ways. So I think Samuel Williams will want to prevent that, and I think he will not accept the invitation, because if there is ever a better implementation in the future, you know, he does not want us to be locked into async in a way, right? You know what I mean? So he wants to give equal opportunity to other potential async libraries in the future.
Oh, that's very interesting.
Yeah, it is an interesting perspective, and it just shows how humble this guy is. You know, like if anyone wants my Ruby code in core Ruby, I'd say yes immediately. But this guy is really, really thoughtful, and he's really, you know, forward thinking. You know, and what's the best for, you know, the whole community long term. So yeah.
Just as a side note on that, I did a whole bunch of work. Just, you know, hey, there's a core Ruby library, and it was really good, and you know, it's not in the core, or actually, it was in Rails. It was WebSocket Rails. Someone wrote WebSocket Rails. It's like 2 or 3 people. It was totally private, but and I started using it at a time when it was only like, well, 1 or 2 maintainers. I actually worked with the maintainer, and like, he did a great job, stepped through me, you know, worked with me on getting my implementation going. And then I think Rails 6, they had their own version of WebSockets. And they what the Rails team did was literally take the WebSocket Rails and just put it inside Rails. You know, so it will somehow, some way, it will get into like the core if it's good enough in some, you know, in its own way too, right? And
yeah,
maybe sometimes it's with or without the permission of the authors.
Yeah. Look, it may be a good thing. You know, it will definitely gain more spotlight. You know, people will notice it more because it's official now. You know, businesses will be less reluctant to use it because, again, it's in core. It will, you know, it will be supported long term. You have that guarantee. So I agree. There are some benefits to making things official, and you know. So yeah, we'll see. We'll see what happens.
Yeah, this is great though, because one thing, you know, one thing against even Python and Ruby is always like the speed. You know, you know, you always see those programming language speed graphs, right? C is 1 time, Java is almost like 1.1 or something like that, and then Ruby's like 20 times slower, and Python's like 20 times slower and stuff like that. So I think, and this is probably coming to like, you know, we're gonna have a panel coming up. We're talking about developer happiness. And then that's one thing where Ruby really is as a core philosophy, right? We're about developer happiness, and other languages just don't even have that. And I think I was like talking about when you brought up Python has like multiple async implementations, like, oh, well, Python's core value or tenet is, oh, there's only one way to do something, and yet, oh, how many ways are there to do async? How many ways are there to do packaging? How many ways, you know, how many official Python versions are there? You know, 2.7 versus 3 and stuff. And so I think anything that brings Ruby like a little faster, better, but still maintaining developer happiness, it's a fine line, right? Because like you said, like threads are hard, and hey, POSIX threads are hard, and they're just like, as a concept, crazy, very gnarly and probably even worse is debugging them.
Mhm.
You know, you're just like, oh my God, okay, I wrote it once, it worked, but then now I'm debugging it, and I just want to, okay, now I'm just gonna find another job. I'll let someone else debug this, right? So, but no, it's great that you're contributing this to the community and keeping the fine line of developer happiness and performance too.
Yeah. 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 I think async shines in both ways, really is really nice to work with. And again, it's a big performance boost in these, use cases.
Cool. I mean, I think, well, a lot of, if Dan, you're still the MC, so feel free to.
Yeah, I see like people are starting to trickle down or trickle out. So I say let's stop the recording. Thank you again, Bruno, for the talk. So yeah, let me just stop this now.